All right, how are we doing, everyone? Today we are going to talk about how to determine whether a function is continuous at a given point. So we're going to be looking at the definition of what it means for a function to be continuous at a given point, and then trying to apply that in different problems to prove whether that function is continuous at a given point. So the first thing we're going to do is try to build and understand what this definition of continuity is. We have a graph here, and it's a little hard to see on the screen, but I need to include the first three rows of this table, so that's why it's a little smaller. What you can do first, so you can pause the video, I want you to fill in the first three rows of this table, and the last column asks you whether g of x is continuous at that point. So based on what you see in these first four columns, you're going to try to make an inference as to what must be required or what the necessary conditions are for a function to be continuous at a given point. So again, just fill in the first three rows, and then we'll have a discussion about what it means for a function to be continuous. All right, so hopefully you've had a chance to fill in those first three rows. I have them filled in on the screen, and now we're going to discuss. So at x equals -6, the first question is the function defined? If so, what's its value? So at x equals -6, which is right here, the function is not defined. There's a hole in the graph, but the limit does exist, right? So both one-sided limits are 5, which means that the actual limit's going to be 5. However, when we look at this last column, the function is clearly not continuous because there's a hole in the graph, right? So the function stops and starts again at x equals -6. If we look at x equals -3, which is this point right here as well as this point, the function is defined, but the two one-sided limits are not the same. They're different, which means the actual limit will not exist, right? If the two one-sided limits are different, then the actual limit will be dnd. And this also means that the function is not continuous, right? We'd have to pick up our pencil to keep tracing the graph as we move past x equals -3. Now, if we look at x equals 0, which occurs right here, the function is defined, right? It has a value of -1. And both one-sided limits are also equal to -1 because the function is approaching the same value from both sides, which means that the actual limit will also be -1. And we can tell from the graph that this function is continuous at x equals 0, right? We can keep tracing the function right on through that point without picking up our pencil. So after looking at these three different spots on the graph, based on what we've seen, what needs to be present for a function to be continuous at a certain point? So maybe take 30 seconds, write down what you think needs to be present or what the conditions are, and then we will discuss together. Okay, so first thing is a function must be defined. So g of x is defined. Okay, if it's not defined, there's going to be a discontinuity, which means it can't be continuous. Now, if we take a look at these columns right here, okay, these three columns dealt with the limit. Now, for a function to be continuous, the limit will have to exist. And there's a couple different ways of writing this. We could show that the one-sided limits must be equal to one another. But for now, all we're going to put is the limit as x approaches a of g of x exists. Okay, so the function must be defined, the limit must exist at that x value, and the function's value at that x value must be equal to the limit. So, and I just realized we made a mistake up here. I should have said g of a. So g of a is defined. And the third condition is that g of a must equal the limit as the function is approaching a. So if these three things are true, then you will have a function that is continuous at x equals a. Okay, so again, these are extremely important. You're going to use these to justify in questions not only in this lesson but on the AP exam. In almost every AP practice book or practice test you take, there's some sort of question that deals with showing that a function is continuous, and you're going to have to talk about all three of these criteria. So let's erase this, and let's do two examples. Then we're going to cut this video. We're going to do two parts for this lesson, because if I do one part, it's going to stretch and be a little bit too long for one video. So here it says the graph of the function g of x is pictured to the right, and it has several x values at which the function is not continuous. For each of the following x values, use the three-part definition of continuity to determine if the function is continuous or not. And we have our x values down here. So we have -8, -6, and -4. Now, to prove that something's not continuous, you don't have to show that all three of those criteria break down, right? You just have to show that one of them is false, or one of them doesn't hold up. Okay. Now, if you want to prove that the function is continuous, you'll have to go through each criteria and show that it stands up to the test. But if you just need to show that it's not continuous, you just have to show that one of those criteria doesn't work. So let's take a look at the first one, x equals -8. Let's pull out a pen rather. So x equals -8. We have a couple things going on, but it deals with these two sections of the graph. So the function is defined, right? We have g of -8 is equal to 4. Okay. Then we need to check the limits, right? So we'll call this, you know what, I'm going to do this up here because I can already tell I'm going to run out of space. So criteria number 1, g of -8 equals 4. You don't have to write out the words g of 8 or g of -8 is defined. By showing that it equals a number, you've shown that it's defined. Number 2, we need to show that the limit as x approaches -8 of g of x exists. And to do that, you do need to show the two one-sided limits. So we need to show that the limit as x approaches -8 from the left-hand side or the negative side of g of x, not g of 8, is equal to the limit as x approaches -8 from the positive side of g of x. And we can see as we approach from the negative side, the limit's going to equal -5. And as we approach from the positive side, the limit also equals -5. So this statement's true, and then we can say thus the limit as x approaches -8 of g of x equals -5. Okay, but all that work would be required for the second criteria to show that the limit exists. Okay, you do have to talk about those one-sided limits. Now, third criteria, we need to show that the value of the function is equal to the value of the limit as the function's approaching that x value. So we would need to say that g of -8 equals the limit as x approaches -8 of g of x. This statement would have to be true, but it's not, right? These are not equal to one another because 4 does not equal a negative 5. And you could put another line here that says 4 does not equal negative 5. But as long as you've shown that earlier in the problem, you're okay. So we've now shown that this function is not continuous at x equals negative 8 because the value of the function is not equal to the value of the limit at x equals negative 8. So not continuous at x equals negative 8. All right, we'll actually do one more, and then you guys can try the other one on your own. Let us do, let's see. We will do the third one. So we'll come over here. I'm going to get rid of this just so it's not crowding. And we're going to do number 3. So we're looking at x equals negative 4, which is going on right along this axis. So step 1, show that g of negative 4 exists. And it does because it equals negative 5. Then we need to check the limits. What's going on? Okay, so the two one-sided limits, the limit as x approaches negative 4 from the negative side of g of x must be equal to the limit as x approaches negative 4 from the positive side of g of x. So we just need to check and make sure these limits pan out. As we come in from the negative side, we see that this limit is negative 5. And as we come in from the positive side, that limit is negative 2. So this is a false statement, right? Negative 2 is not equal to negative 5. Thus, g of x is not continuous at x equals negative 4. So again, we even have to check the third criteria, right? Because if the limit doesn't exist, right, because the two one-sided limits are not equal to one another, then we don't have to check to see if the function equals the value of the limit because the limit does not exist. So why don't you guys try number 2, work your way through all 3 of those criteria, and then I will see you for part 2 of this lesson in the next video. This is Mr. Fawcett. Have a great day as always.